Okay, today's lesson is going to focus on the properties of exponents. We're going to start out with some things that we've talked about previously, and we're going to build on those so you can learn how to do some calculations with exponents in a quicker, simpler way. So fill in today's date and title your pages. These are going to get taped in on page 97 and 98. First, to fill out your vocabulary, on your note sheet, we know that when you have a number raised to an exponent, in this case we have the number 5 raised to the third power. What this means is we take the base of 5 and we multiply it out against itself 3 different times. The exponent tells you how many times, the base tells you what you're actually multiplying. So it's a way to represent repeated multiplication, and it takes up smaller space when you just say 5 to the third power instead of having to say 5 times 5 times 5. So again, in the example, 5 is the base, 3 is the exponent. And one of the things we do have to remember is that when your number is raised to the first power, you actually get the answer that you started with. You get the number's value. So 8 to the first power is just 8. 50 to the first power is just 50. There's only one factor that you're working on. Alright, here's something that is a little confusing to students. Any number raised to the 0 power is actually equal to 1. We don't want anything equaling 0 when you do repeated multiplication. So the rule is if you have a number, for example, here's 12 to the 0 power, it gives you the value of 1. 100 to the 0 value also gives you the value of 1. So it doesn't matter what power or what base you start with. If you have a 0 power, the answer is going to be 1. So that's something that you're going to want to put a little star on. It's hard for students to remember that fact. So that's something we'll make sure we practice. Okay, here's another property of exponents that's going to help you do some calculations quicker and easier. When bases are being multiplied, when like bases are being multiplied, their exponents can actually be added together. So the example I have for you is right here, 2 to the third power. If you have to multiply by 2 squared, you could remember that 2 to the third power represents 2 times 2 times 2, and 2 squared represents 2 times 2. All these in a row actually represent 2 to the 5th power because there's 5 factors repeatedly multiplied. And again, a shortcut would be if you just looked at the original exponents, 3 plus 2 gives you 5. On the next part of your notes where the vocabulary is, if you have to take like bases and divide them, these exponents can actually be subtracted. So the example I have for you is if we take 2 to the third power and we have to divide by 2 squared. Again, remember 2 to the third power represents 2 times 2 times 2, and 2 squared represents 2 times 2. Because division of a number divided by itself cancels out, gives us 1 basically, you can have this pair cancel and this pair cancel, which just leaves you with 1 value of your base, 2 to the first power. If we were to use the little shortcut rule and we take to the third power and we take this exponent and we subtract this exponent, that's where we could also get the answer quicker and easier. Now the last part of this lesson is to know how to work with a power raised to another power. When an exponent is raised to another exponent, the exponents can actually be multiplied. So here's an example. 2 to the third power is being squared. This means everything inside will multiply against itself. There's 2 different factors here. 2 to the third, remember, represents 2 times 2 times 2. Here's the values of the other 2 to the third. So in total you have 6, 2 to the 6th power for that problem. If we had originally just multiplied our exponents, 3 times 2 would have gotten us the 6th answer right away. So all of these little shortcuts are very helpful when you're working with exponent calculations. Now what we're going to do is practice those exponent rules. Here's an example that shows you that you have bases of 8 raised to a power. We can simplify this by keeping the base, and because we learned about multiplication of like bases, the shortcut is the exponents can be added together. If we have 7 here, 8, 9, 10 total, the solution would be 8 to the 10th. Here's an example of division. We learned that when you have division, you can simply subtract your exponents. So if that's the letter Q, we have 9 minus 6 is 3. So we will end up with Q to the third. Here's an example of a power raised to another power. So our base 4 stays the same. 8 times 2 would be 16. Because again, when you simplify power to a power, we said you can multiply your exponents to make the calculation quicker and easier. This example is trying to get you to practice having a value to the 0 power has a value of 1. If you're multiplying 1 times, in this case, m to the third power, you will still get m to the third power for your final answer. Number 5 is giving you 2 examples. You have to simplify the numerator of the fraction first. So under multiplication, we learned you can just add your exponents. That turns into 7 to the 7th power. And then what we can do is we can simplify using division. Under division, we learned you can subtract your exponents. So we will end up with 7 to the 4th power when we're done. Power to a power gets done first. We will multiply our exponents for power to a power to create a simpler expression. And then we have to focus on the rule for multiplying. When there are like bases, you keep your base and you add your exponents. So this will turn into b to the 19th power. In this example, we should do our division first to simplify this part of the expression. We will end up with 15 squared because you're going to subtract your exponents. And then, because of the multiplication problem that we have here at the end, you're going to add your exponents to show that that's how many you have. So we end up with 15 to the 9th power. And again, number 8, you're practicing with something to the 0 power, which is 1. We also know that raising a power to a power, you can simplify by multiplying. So this would simplify to give us w squared. If we're multiplying by 1, we still end up with w squared. On the back of your note sheet, there's some other examples that we can work on. It does say evaluate this time, and evaluate, remember, means you're looking to find the value. And it says do not leave exponents in your solution. So what we could do is we could just use our calculator. 5 squared is 25. If the other value is also 5 squared or 25, you can multiply these together and you can get your value. You can also type that whole thing into your calculator right from the beginning, and it should give you 625. In the middle, we have 9 to the 5th power. We are dividing by 9 squared. If you were to use your calculator, you should be able to type that in the way it looks, although your calculator is going to have a slash where the divide symbol is supposed to be. If we were to use our exponents to simplify it, we would realize that this simplifies to be 9 to the 3rd power. 9 to the 3rd power has the value of 729. So either way you do this problem, you should end up with 729. This one we can simplify by doing power to a power by multiplying, and then we can simplify by subtracting because there's division here. We see that it gives you 2 to the 1st power. So again, you could type this whole thing into the calculator, but it is simple to simplify if you know your exponent rules. You will just end up with 2. On this example, you have power to a power, so you'd multiply, and this would simplify to be 8 squared. Remember, 8 to the 0 power is 1. So when you take 8 squared times 1, 8 squared is just 64. So again, we're getting the value. We're not leaving our answer in exponents this time. This would give you 1 to the 8th power because you're multiplying power to a power. This would give you 1 to the 12th power. Now remember how 1 works. 1 times 1 times 1 times 1 times 1 times 1 times 1 is still 1. Again, if we have 12 different ones to multiply out, we're still going to get an answer of 1 when we multiply them all together. This one is going to stay 6 to the 9th power in the top. If we simplify in the denominator, we get 6 to the 6th power. If we use our exponent rules to simplify, we're going to get 6 to the 3rd power, and 6 to the 3rd power has a value of 216. Again, you could have typed this in using your calculator right from the beginning if you wanted to. On the bottom of the back of your note sheet, we are going to use our exponent rules, and we're going to look and see if we agree if these equations are true or false. In this example, we're practicing power to a power, and in both cases you would multiply to get your same exponents, and because we have the same base, this is a true equation. On this side, we are practicing the exponent rule where you have to add your exponents. So this would give us 13, the base, to the 11th power because we added exponents. In this case, we have a power to a power. And the rule for power to a power is that you actually multiply your exponents. And this is actually giving us a false equation. 13 to the 28th power will be way larger than 13 to the 11th power. In this example, they want us to remember that anything to the 0 power has a value of 1. So if we know this is multiplied against 1, then we know that y to the 5th times 1 is still y to the 5th. Y cubed on the bottom allows us to use our subtraction shortcut rule that says we end up with y squared on this side. On this side, they want us to raise a power to a power. So we are going to see that y squared equals y squared. This is a true equation. And number 18, q to the 0 power has a value of 1. 1 times q to the 5th is going to stay q to the 5th. And if we have q squared on the bottom, we could use our shortcut rule that has us subtract exponents. On this side, we have to do our power to a power rule, which has us multiply exponents. And then we have to use our shortcut rule for division, which has us subtracting exponents. So we end up with another true equation. As far as summarizing today's lesson, you want to know that your exponent properties can help to simplify exponent questions quickly and easily. Now to practice, you're going to take a look at the sheet that you've been given with your notes, and you're going to try these 10 examples. Your job is to find the value of x that will make each equation true. So it's working backwards a little bit with the exponent rules that you just worked on. We would have to take 8 to some power to give you this value of 1. And there's a special thing that we looked at in our notes that we saw, and that's something that you need to take a look at. Try these 10 examples, and we'll go over them in a second. So pause the video, and then you can come back and check them. Okay, checking answers. This is the one rule we said you'd have to be careful to remember. Anything to the 0 power is 1. So if we need 8 to somehow turn into a 1, we have to use a 0 exponent. So that's why x is 0. In this example, we're practicing the fact that if you want your base to remain the same, you'd have to use an exponent that is a 1. 100 to the 1st power is where you get 100 from, so x equals 1. In this example, we need to know that when we have exponents when we have bases that are alike, we need to know that we can add the exponents. So if we're trying to get 12 to the 8th power, we already have 12 to the 4th. We need another 12 to the 4th. So the x value has to be 4. In this example, we're practicing with our division shortcut rule, which says if we're trying to get 6 to the 6th power, we need 10 minus something that gives us 6. So 10 minus 4 is the only way you're going to get 6. So that's why x equals 4. For the next example, we do have to work backwards. We have to end up with q to the 8th power, which means we need a value up here that would take and subtract 6 and give us 8. 14 minus 6 is the only way to get 8. So if we're focusing on q to the 14th power, we already have q squared. When you raise a power to a power, you need to be able to multiply to get 14. So that's why 2 times 7 gives you 14, and then the rest of the problem works. So x is 7. In this example, we simplify, we get 3 to the 6th, so we would need a combination of 5 plus 1 more, or 6 on that side, so x equals 1. For number 7, we have 7 to the 18th power when we simplify this side, so 3 times 6 gives us 18 on this side. Over here, we get 2 to the 18th, so again, 2 times 9, x equals 9. And at the very bottom, we have 4 to the 8th power, so we need an 11 on top. And when we simplify this, we end up with 11 to the 6th. So in order to get 11 to the 6th on this side, you need to multiply power against power.